Hello, today we are going to look at Bubblesort. It is also known as sinking sort and it is one of the most basic sorting algorithms available. Let us consider this example. Once you have solved this example, you will understand the intuition behind this algorithm. What we are going to do is we are going to find the right place for the number 8. Number 8 is the biggest element here and the rightful place for number 8 is on the rightmost side. And we start from left. So we start from this side and we compare. So is 7 greater than 4? Yes, it is. So we swap. Okay, is 7 greater than 8? No, it is not. So we do nothing. Is 8 greater than 3? Yes, it is. So we swap. Is 8 greater than 2? Yes, it is. So we swap. And so after doing all these things, all these comparisons, we have ended up with an array which has elements in this order. And here 8 is in the right position. This is pass 1. Now pass 2, we start again. We ask, is 4 greater than 7? It is not. Is 7 greater than 3? Yes, it is. So we swap. Is 7 greater than 2? Yes, it is. So we swap. Is 7 greater than 8? It is not. So we do not do anything. And now the entire array has elements in the following order. This is pass 2. So after pass 1, one element was in its right position. After pass 2, two elements are in the right position. So we go with the third pass now. In pass 3, is 4 greater than 3? Yes, it is. So we swap. Is 4 greater than 2? Yes, it is. So we swap. Is 4 greater than 7? No, it is not. Is 7 greater than 8? It is not. So we end. So after pass 3, at the end of pass 3, we have elements in the following order. Now we start again. Is 3 greater than 2? Yes, it is. So we swap. Is 3 greater than 4? No, it is not. Is 4 greater than 7? No, it is not. Is 7 greater than 8? No, it is not. So they come as is. So after pass 4, this array is sorted. We should note a few points here. What has really happened is an element has bubbled. So we kind of started here and we bubbled, right? It is also known as sinking sort in the sense that the largest element sinks to the rightmost side. The other thing to note here is that after pass 1, when 8 was in its right position, then in pass 2, we really do not need to compare 7 and 8. Because 8 is in the right position, 7 doesn't have to be compared to 8. Likewise, in pass 3, 4 doesn't have to be compared to 7 and 7 doesn't have to be compared to 8. And in pass 4, 3 doesn't have to be compared to 4, 4 doesn't have to be compared to 7 and 7 doesn't have to be compared to 8. Right? These are unnecessary comparisons because these are all the elements that have been put in their right places. The last thing to note here is that after pass 1, we had one element which was in its right position. After pass 2, we had two elements, and after pass 3, we had three elements. It doesn't mean that after nth pass, n elements only will be in the right place. It does not mean that. It means after nth element, at least n elements will be in their right places. Given the nature of the data, it could be that there are more than n elements which are in their places, but it is guaranteed that n elements will be in their position, in the right position after the nth pass. Let us now code the algorithm. I use Python. So I define a function called bubble, which takes an array as an input. And what I do is I iterate over the entire array, right? So -1 because in Python we use zero-based indexing. And in just a couple of minutes, I'll show you, I'll explain why I'm using two for loops here. So here, what we did was we iterated over the elements and found out the biggest one and its right place. This was the inner for loop, the j variable. And these passes that we made, pass 1, pass 2, etc., this was the outer for loop. So in the first pass, so we say for I, and then we start from 7 and we go all the way till the end of it. Let us first complete this code, and then what I'll do is I'll actually embed some print statements for better understanding if it is not clear. So now all we have to do is just say if the jth element is greater than j plus 1th element, then swap. And in Python, the swapping is very easy, or I like the way they swap. I don't have to create a temporary variable. All I have to do is just say okay, this is akin to saying if you have two variables x and y, then x comma y is equal to y comma x swaps the two values. Okay, and we are done here. Actually, we are done. If it is greater than this, then we do it, and we have nothing else to do. So okay, so now we'll probably define the main function. I use, or this VI editor seems to be based out of an old edition, I guess, because it uses certain things that the older Unix systems used to have. Anyway, so let's have the values that we had were 7, 4, 8, 3, and 2. So we just want to print out the array once before it is sorted. Then we call the function on this bubble with array, and then we print it again. Right. Now we have to run it. So we run it here. And you see the array is sorted. But you have missed out on the most explicit points as to what happened internally. So let's put some print statements. Okay, I say pass num equal to 1. This is essentially to pass every time we make a pass, the complete pass, to print that. Then say I'm talking about what are the elements I'm comparing. You don't have to bother about the syntax here. And I'm comparing jth element and j plus 1th element. Right. Here, if I'm inside this condition, that means I have to swap the two values. So I'm just using some backslash t's to format the output a bit. And swapping spelling is wrong, which should be okay. And one more print statement perhaps, which is say after I have swapped. So I will say and I'm printing the array after that. Okay. And of course, after this, I have to, once I'm done with this loop, so once I'm done with the inner loop, then I have to increment the pass num. Isn't it? And I have not printed the pass num, so I need to print that pass num also. So I will print it after here. And I'm printing the array. Just be with me for this while I've written this entire code. You will see in the output exactly what this does. Okay, so we have 74832. Pass 1 takes the array. It compares 7 and 4 first and sees that 7 is greater than 4, so it swaps 7 and 4. And after the swap, it is 47832. We are still in pass 1. Then 7 and 8 are compared and nothing wrong is found. Then 8 and 3 are compared and 8 is greater than 3, so they have to be swapped. So it says swapping 8 and 3. And after the swap, this is the array. Then 8 and 2 are compared and again they are swapped, right? So after the swap, 47328, this is the order in the array after pass 1. Okay, so in the beginning of pass 2, it is the same array, right? Now 8 is in the correct position, so we start again comparing 4 and 7, nothing to be done. 7 and 3, yes, they have to be solved, so 43728. Then comparing 7 and 2, so 7 and 2 are to be solved, 43278, and comparing 7 and 8. This is where I said that this doesn't have to be compared because 8 is in the right position, so 7 possibly cannot be bigger than 8, right? And how do we prevent it? We'll see in just a bit. So after pass 2, 7 and 8 are in the correct position. Pass 3 is to be done. Pass 3 compares 4 and 3, they have to be swapped. 4 and 2, they have to be swapped. So we get 32478. Comparing 4 and 7 of no use, comparing 7 and 8, that is of no use. Okay, and for the final pass, 3 and 2 have to be swapped, and after that everything is in the correct order. Okay, so now here we made a few unnecessary comparisons, comparing 3 and 4, 4 and 7, 7 and 8. So let us understand what we did. We had two for loops, right? So for I in range, and let me just call this the length of this thing as length, assuming that we are using 0 to array's length minus 1. Okay, and then again we iterated over all the elements for j in range length. This was despite the fact that the end of this for loop, there was always an element in the right position. We saw that after the first pass there would be one element in the right position. After the second pass there will be two elements which are in the right positions, and we do not want to compare those elements. So all we have to do is say instead of this range of len, we have to say minus I. Okay, what is I? I is 0 first. This is the first pass. Then I gets incremented to 1. So this is the second pass. Then I gets incremented to 2, and this is the third pass. At the end of the first pass, one element is in position. So I can here in the first pass, I can say if I iterate till len minus 1, then I will skip the comparison of 7 greater than 8. Okay, here I is 2, so here len minus 2, if I say, then I will skip the comparison of 4 greater than 7 and 7 greater than 8. Is this part clear? I hope it is clear to all of you guys. So that is what we have to do in our code now. So in our code here, in the loop for j variable, I have to say do it for the entire length of the array minus 1 minus I, and that should remove all these unnecessary comparisons. Let's run it once, and now you see we are not anymore. Earlier we were comparing 3, 4, 4, 7, 7, 8, but now we are not comparing those. We are not comparing anything, which was like after the pass 1 we are not comparing between 7 and 8. I'm sorry, not after pass 1, after pass 2 we are not doing this comparison of 7 and 8. After pass 3 we are not doing the comparison of 4, 7 and 8, right? Now I've deleted all the print statements. We understand the code, how it works. There is a more intuitive way. I prefer a different way of writing this entire code. The code is very simple, right? The code is really very small, but I can do something else here. What I can do is, instead of saying for I in range len of array minus 1, so here instead of going from 0 to len of array minus 1, I can go len of array minus 1 to 0. And what's the benefit of that? We'll just see. So what I will do is, here in Python, this means that I'm going from source to destination with incremental steps of minus 1. Okay, and now I say for j in range I. So now I is actually starting from the length of array minus 1 going all the way to 0, and I'm saying j will go from 0 till I. I is, instead of going from left to right, I is going from right to left. Okay, in steps of minus 1. J will do comparisons of all the elements till array of length minus 1 minus I. So if this is where I is, say this is I, then it will stop, it will not compare this part. So after making this change, the new code, let us try to run this code. And you see, it is sorted correctly. And suffice to say that actually it does not really do all the unnecessary comparisons. I could have actually added the print statements, but that's okay. I think you can probably check it out yourself if you really want to. So Bubblesort basically uses 2 for loops. Then it just compares the value of jth element with the j plus 1th element. And because it uses 2 for loops, it means the complexity of it is of n square, right? For smaller, if you have very small data set, then you can use Bubblesort. Of course, n square cannot be used for some bigger data sets, but this is one of the most basic sorting algorithms one must know. Okay, I hope you found this video useful. If you have any comments, please do share. Also, please do like, share and subscribe the video and the channel. That motivates me to create more and better content. Thank you.